Hello, in this video we're going to talk about section 2.5, which is modeling with linear equations and inequalities. And really what modeling means is setting up word problems. So these will all be word problems that involve our straight line equations. And then we'll do maybe a couple inequalities too. So let's see an example. First, this one says it costs $158.05 to rent a compact car. The daily charges are $45.98. And then it says define the variables. So hopefully remember that a variable just means an unknown quantity. And in this case, like a big hint is actually if we look ahead to part B, where they say, well, we don't know how many days we're going to be renting this car. And so that's the unknown. So we're gonna let X equal the number of days we're going to rent the car. Of days rented. And it's always really important to define your variables, right? Especially in any word problem, but especially in these algebra problems, it's gonna be helpful to write it out in words what X equals. So then it says set up a table. So in this case, our table is going to have values of X, and X is the number of days. And then we want the total charge. So that's going to be our other variable, which we can call Y, or we can call something else. Maybe I'll call it Y. Total charge. So here, the number of days that they're asking us to solve for are 0, 1, 2, 3, and 4. So now we just got to figure out, based on what they told us about this car rental agreement, how much am I going to be charged? So the weird thing is that hopefully if I rent a car, it's not for 0 days, but I guess if I just rented it for a couple hours, maybe that would count as 0 days. So then this says, no matter how many days I have it, I'm going to be charged $158.05. So that's our starting charge, $158.05. But then they're going to add to that. And that's what these daily charges mean. So for one day, they're going to take that $158.05 and then add to it $45.98. And in these problems, you can definitely use a calculator. We're going to see some pretty complicated numbers because these are real life situations. So it is fine to just type this in a calculator. And when I did that earlier, I got $204.03. So that's the charge for one day. So now let's scoot this up and figure out, well, how do I do this for 2 days? And what's going to happen is that we'll have to add 2 of these daily charges. So I still get charged $158.05. That's not going to change. But now the $45.98 has to get multiplied by 2 days. And again, this is a calculator problem. You don't have to try to do this by hand. But when I put this in my calculator, I got $250.01. Now basically, all that happened is that I added another daily charge of $45.98, all right, to get from here to here. But I also want us to see how this number of days sort of plays into this charge, so I don't have to always make a whole table. That's our goal too. So the only thing that should change for 3 days is that I'm going to replace the 2 with the daily charge with a 3. So the $158.05 stays put, but now the daily charge we multiply by 3 days. And when this goes in a calculator, we get $295.99. All right, last one. 4 days, I have $158.05 because that's the car rental rate, no matter how many days I have it. But now I need to multiply $45.98 by 4 days. And the calculator told me that that would be $341.97. Even though I'm using a calculator, notice that I'm writing down what I'm going to put in the calculator before I actually type it in there. And this is exactly how you need to show your work. So using a calculator is great, but in order for me to grade how you're doing these, it's important to write down what you're typing into your calculator. All right, well, let's see what part C is asking us for. It says write a linear equation. So equation, hopefully remember, just means equals with two sides to it, showing when the total charge will equal $617.85. All right, so we need total charge, and the when means that the number of days is X, and that's where we started this problem. So now instead of 2, 3, 4, or even 1, or, I wonder if 0 would work in this. Let's try it. $45.98 times 0. Would that just be $158.05? It totally would, because multiplying by 0 makes that 0. So the pattern is that no matter how many days it is, that's what we need to multiply by here. All right, so total charge, hopefully we see in this table this pattern that it's $158.05 plus $45.98, and then instead of a number, we're going to use a variable here. And then set that equal to $617.85. Now this, of course, is something that then we could solve for X. We could subtract from both sides and divide. Actually, let's go ahead and do that, because even though I don't have a lot of room, I want to make sure we can deal with these ugly numbers too. Right, that you just would subtract $158.05 from both sides and then divide. And I just realized we're going to do one of these that's just like this in a future video, so I'm not going to worry about finishing that one. All right, but hopefully the setup part makes sense. That's really what we're trying to get in this first video here. All right, let's try another one. Assume that the average monthly rent of a one-bedroom apartment in Portland was $1,145 in January 2015. Assuming that rent rises by $13 per month and that this trend continues, write a linear inequality. Now, we haven't talked about inequalities yet, but all that means is less than or greater than or less than or equal to or greater than or equal to. We dealt with that a little bit in chapter 1, but we are going to do more of these in chapter 2 next time. But we're going to just at least set one up in this one. So what I want us to use as sort of a model, and if you look up at this previous one, what we tend to see is that we'll have some kind of starting amount and then some kind of rate that we multiply by our variable, and that will equal our ending amount. So this is the model I'm going to use for most of the word problems in section 2.5 and even beyond that too. So in this case, our starting rent is $1,145. And then we read the problem to see what the rate is. And it says $13 per month. So in this case, the rate is 13. And the X variable that I'm multiplying by is the months. So that per month tells us that X is the number of months. And remember, we always want to write somewhere what X equals in words. And it doesn't have to be a full sentence and just write an X equals months, but somewhere in words, let me know what we think the variable is. So that means if I rent for 1 month after January 2015, my rent would go up $13. 2 months, it would go up $26. 3 months later, it would go up $39. And then I stopped being able to multiply by 3 very well. But that's all we're saying, is that we're taking 13 and multiplying by the number of months to find out how much the rent rose. And then the ending amount that we want is $1,500. What makes this an inequality is this word exceed. Exceed is one way to say greater than. So So this is still linear. X is only to the first power, and it is still something we could solve for X, but it's a little different in that they put a greater than sign, and we'll do more of these later. Let's try this sort of the same situation with the same starting amount. So we're going to take our starting amount of $1,145, but now we have a different rate. So the rate is $100 per year. And what that means is X has to be the number of years because of the way that rate is set up. All right, so let's start with our starting amount. So the starting amount is $1,145 plus the rate of 100 times X for the number of years. So after 1 year from 2015, the average rent would be $1,245. After 2 years, we would add $200. After 3 years, we would add $300. And then this one says remain below. That sounds like a less than. So we want to keep it less than $1,500. And again, we'll worry about solving these in future videos, but for now, we wanted to just focus on setting them up.